chapter 1, section 2.3, which is actually section 4, right? So in this, we're going to do word problems. So the first one is volume of a cylinder is power squared h. Find the volume of a cylinder with a radius of 9 and a height of what? 7. We tend to refer to these as chugging plugs for some of these word problems that we're going to be dealing with. Okay? So answer exactly using the word pi for pi. So volume equals pi r squared h. Find the volume. So it's just substitute, right? 9 squared, height is what? Try. So leave your answer with pi, meaning pi as a symbol, not multiplied in. Does that make sense? That's what that means. So what's 9 squared?
81.
81. What's that going to give you?
557.
How much?
557.
557 pi? Yeah? I don't know. Y'all agree? Yay or nay?
Yeah.
Yes? So what do you think about that one?
I got 567.
Oh, 567.
Okay.
567.
And 8 times 10 is
567. There. That's what we put, right? Okay, good. So 567. Pi centimeters cubed. Now, they didn't ask for the units, but volume will always have cubic units, correct? Period.
Is that how the XYZ homework answers be like that?
It'd be just like it's right here. Boom. 567 pi.
Okay.
Okay? And that's what you put in it. You wouldn't have to put units unless it had a drop down or something over there that said units, right?
Okay.
Yeah, it's okay.
Yes, you put in 567 pi. And what that'll do is, if you type that in, it's going to convert it to this.
Okay.
You got a little preview thing? Y'all remember that? It's that little preview in it. It'll go like, I'm writing it in code. What they really look like.
Okay.
That's what.
So we have to do the centimeters.
Nah, I just put that in because I like talking about units.
So why would we divide first?
You don't know what.
So if we look at this, it says, hey, solve for width. Perimeter is 2 times the length plus 2 times the width, right? Correct? We got to solve for it. Now, we got to take this information that they're giving us, use the formula above to find the width of a rectangle whose length is 10 and whose perimeter is 34. So, can you find the width? Can you plug in the information? And can you solve for a unknown? Because that's really what you're doing, right? Yes? Okay, good. Do you agree with my substitution of the information given from the problem? Yes or no?
Yes.
Okay. So guys, from here, it's no different than what we did back in the previous. Okay? So 34 is equal to 20 plus 2. Guys, when we solve for a variable, we're trying to get the variable on one side and everything else on the what? That's right. So we're going minus 20. So that's going to give me 14 equal to 2. Y'all agree with that? Yeah. Then divide those sides by what? So we find that the width is how much?
7.
Okay, so the width is 7.
But it's not the
Oh.
on the top though.
No, you're right. Let me do it. I just saw what that was. Okay, I'll do it.
That's what I almost got confused about.
Y'all remember literal equations? Where it says solve in terms of another variable? That's literal equation. So let me, the first one is right now. So I'm gonna move that, right? That. Let's go back. Let's go back. That neat. Oh my God. I know. You don't want it, you got it, right? Got it churning. this down here. And let me move this here, down here. Good. So let me show you what they're talking about in linear equation. So it's P equals 2L plus 2W, right? So what they're wanting you to do is solve this equation in terms of W. So let's think about what's happening to W. W is being multiplied by what? 2. And then added to who? 2L, right? That's the only thing that's happening to it. Y'all agree?
Yes.
So once you identify what's happening to W, if you were reverse that, it's being added to 2L, what do I need to do? So P minus 2L equals what? W has been multiplied by 2, I need to do what? So this, P minus 2L 2, that's really what they're wanting for up here. Does that make sense? Yes? No?
Okay, so you need to get rid of the W.
Yeah, well, I'm solving the equation in terms of W for the top part. And then the bottom part is, here's some information, plug it in. Well, I just plug the information in the equation that we already know, right? Perimeter. And you can do that, right? But you still got to do this first part. So if I got to solve for W, that means I got to get 2L over to the other side. Y'all agree? Yes? So I minus it. Y'all with me there? When I minus that, that gives me P minus 2L equal to 2W. How is the 2 attached to the W? Multiplying, so I need to do what? Divide. So I'll divide P minus 2L by 2 as well, right? And that's when width is equal to the perimeter minus twice length, right? If you think about that, perimeter minus twice length would give you twice the width, right? Divided by 2 would give you the what? The width, correct? So that's what they're doing. It's a literal equation, solve it in terms of no.
So if you divide 2 on this side, 1 divide to the other side.
I did right there.
So it be P minus L.
Because that's P over 2 and minus 2L over 2. You cannot simplify that 2 under there. Mark it out because you got a 2L and a 2. That, you bring up a good point. So this is really, so I could write it like this, right? P over 2 minus 1. If I wanted to, right? Because this 2 is not only under the 2L, it's also under the who.
So it's because it's inside of an equation, you can't simplify out the equation.
If you've got a denominator over more than one thing tied together by addition or subtraction, then that denominator goes for each part. We say term, right? So this 2 goes to this P as well as this negative 2L, right? That's how I wrote it here. If I were to split it, how many of y'all ever seen this? Make your heart and break it, right? Y'all seen that? Right? Yeah, a long time ago. Here, this 2 goes with this P as well as this what? So I've got P over 2 and negative 2L over 2. Now I'm going to split it apart, correct? And that's what gives me up here. This one. And then if I wanted to simplify, it would give me what? That. But they only wanted, guess what? This right here. Fair enough? Yeah. Okay. All right. You go back and look at that, kind of scratch your head on it.
Is it basically the same thing?
It is. It's just written in a different variable, right? In terms of a different variable. That's all you're doing. Right? So I got 3 variables, correct? As long as you give me 2 of them, I can solve for them, correct? In literal equations, which that top part is what that is, they're having you solve in terms of that variable that you need. You did this in science classes a lot, right? Y'all remember that? You're given acceleration, or you're given time, or something like that. Solve something, I don't know, energy or something, I don't know, right? It's been a long time. But that's where you use it. Alright, look at that. Formula F equals mv squared over r. So force is F, right? Velocity is V, M is mass, and resistance is big R, right? So find R when M equals 54, V equals 7, and F equals 441. So what are they really doing?
They want you to change the equation.
You could, right? Y'all remember ratios and proportions? That it's AD, right, equals BC, right? Yeah? Right? Yeah? Okay. So mathematically, if I were to multiply both sides by R, and then divide both sides by F, this cancels, and guess what cancels? Correct? Now, I want you to look at this, because this is an algebraic technique. I'm going to move this up. I'm going to go. On diagonals, things can switch places. Because when I multiplied both sides by R, here up top, it made my R go away and put an R up here, right? And then when I divided by F, both sides, it dropped here and put my F where? In the bottom, right? So on a diagonal, you can take these things and do what? Switch them, right? That's an algebraic technique. Y'all with me? It works like that 100% of the time. But you got to take everything on the diagonals and switch them, right? Does that make sense? So when I switch this, the equation really is R equals mv squared over F, right? Now I can go plug this stuff in and solve for it, correct? Does that make a little bit more sense? All right, y'all go do that. I give you some insights on solving a literal equation. You solve it for numerical.
We'll go back to original.
All right, so what's 54 times 49 over 441? 6? Like evenly? Like no decimals? Period. 6. Okay. Y'all good with that? Okay. So after you work this problem, like on your homework, what do you think you ought to do after you get it correct?
I plug it back in and make sure that was right.
See,
Got it right.
that's checking, right? But what can you do? Just keep working them, right?
Yeah.
Yeah, that's for literal equations. The only way you get really good at is just practice. And here's the really cool part. You see this problem right here? It could be a potential test question, right? So if you know how to manipulate the formula, then how easy is this problem now? Does that make sense? Remember, it's algorithmically generated, correct? Which means who's going to change? Only the numbers. Right? Understand how to work it. Then go from there. Y'all good? Okay, so let's look at this. The sum of two consecutive integers is 7. Find the numbers. Smaller one's this, larger one's this. What the heck does it mean when it says consecutive? What does that mean? Yeah, it's like one right after the other, right? I didn't realize that. Y'all know that? You know where I saw consecutive at? In baseball, in math, consecutive at math. That's a stat. I didn't have a clue what that was. Right? Depends on what you've been exposed to, correct? So consecutive is one right after the other. So x plus 1, x plus what? 2x plus what? X plus 4. Y'all ever heard of sequences or series? This is a series, right? you give me X and what, a value for X, and I can find the consecutive numbers after, right? Correct? So how many of these do I need? 2. So guess what I'm gonna do? Grab 2 of them. What am I doing to these 2? What's that word right there?
And
I will go X plus, guess what? X plus 1, which has to equal what? So I've written an equation now. Can you solve it? Okay. So we find that X is what? 3. So if I were to plug it back into here, that would be what? 3. What would this give me? 3 plus 1 would give me what? 4. So the smaller of the numbers is what? And the larger is 2. So does 3 plus 4 equal 7? Voila. But did I just put 4 plus 1? Who is X? 3. And if in this series, if I wanted the next number, that would be what? 3 plus 2, which is what? 3 plus 3, which is what?
6.
And then 3 plus 4, which is what? So you've got to know this little bit of sequence for the series. Y'all good? Yes,
Why wouldn't you put the X plus 1?
you could. You could. So the question is, would I do it like that?
Right.
You could. To specify that those are the parts. What's set outside those parentheses? 1. So would it change the value of it or the equation itself? No, but it would give you a really good identifier. This is the first part, this is the what? Second part. So yeah, that's not a bad strategy. So if you were to do that, then you know the next step would be everything without a parenthesis, correct? Or they could say Sutton relationship 3 times the third number, right? It'd be 3 times that, right? So yeah, that's a good question. All right. You can figure this one out without writing the equation, but you got to write the equation. You understand me? Okay? Put your heads together, check it with your neighbor. You got a minute and a half. You ready? Go. Logically, how many minutes did we use? If a long distance call is 45 cents for the first minute, 34 cents for each additional minute, if the total charge for long distance call was $8.95, how long was the call? Go. How long was it? Logically. How many of y'all did it logically? Like, you used to have to pay phone bill your portion, right? That's what I mean by logic. Right? How many?
26 minutes.
26 minutes. Y'all agree? How many of y'all say 27? 25?
I got 25.
25? You got 26? 26? Got some 25s, got some 26, right? Okay, logically, let's think about this. If the whole thing was $8.95, right? The first minute was how much?
45 cents.
45 cents. So I would take $8.95 minus 45, right? Y'all agree? Okay, good. So logically, I'd take $8.95 minus 45 cents. La la la. That's what? I got $8.50 left in my bill. That's 2 minutes on, right? This is 1 minute. So if I take $8.50 divided by what?
134,
How much is that?
25,
25 plus 1 is how much?
26.
Okay, so logically, that's where we're at, right?
Yeah.
Okay, so you ready? Okay, so mathematically, how do you do this? Because see, everything they do this in the telephone company. There's a program set up that that knows to do this, right? So somebody had to create a formula, correct? So let's think about this. After that first minute, man, if we didn't have this first minute being bad, we'd be like, okay, it's like 0.34x, right? Like 34 cents times a minute, each minute, correct? Y'all with me? So it'd be like the rate. So I want to show you something. That's what it looks like. The right-hand side of the equation is what the telephone company has plugged in. Now, let me explain. And here's why I use x minus 1. Guys, if it's 1 minute, 1 goes in for x, right? Correct? So 1 minus 1 is what? 0 times 0.34 is what? 0 plus what? So if you talk for 1 minute, how much is your cost? 0.45, right? Correct? If I talk for 2 minutes, let's think about it. 2 minutes. So I put 2 in for x, right? Minus 1 is what? 1. 1 times 0.3 is what? 0.34, right? So I got 34 cents plus what? Right? So that's how you do it. Okay, so mathematically, that's how it works. Now, I'm going to tell you, looking at that on the evening and going, whoo, Lord have me. Yeah, you're probably not going to get there all the way, right, with an equation, correct? So it would really be y equals this, correct? But they're giving you the output, right? They said you got a bill of $8.95. How much does it cost, right? So I'm not sure that I would do the black. But this is a math class, so we got to do the black, right? We got to learn how to create equations based on y. Because if you can think of it, guess what? We can do an equation. I mean, you do realize that you can take a picture of a problem and then it comes back like less than 2 seconds with an answer. Then there's the step-by-step process, right? Y'all understand it, correct? Like, math is all about algorithms, correct? So let's figure out what the algorithm is. Yes, ma'am. No, you good. Come on. Okay, y'all ready? So mathematically, here's the y, and we replace the output with $8.95. If we distribute this, this is plus 0.45, right? Equals $8.95. And then if we combine like terms here, what is that, 9 cents? Yeah. No, 11, right? Is that 11? Yeah, 11. Thank you. So what I gotta do with that 11? I gotta subtract that 11 cents, right? So I get $8 and what? 84? Correct? 11 plus, that's 95. And if I divide both sides by 0.34, ladies and gentlemen, tell me what I get. Oh, that's x. What I get? X equal what? How much? Yes. How much? 84 divided by 0.34 is what? Should be that, right?
I got 26 in my calculator.
Okay, good. We got 26. Okay. What did we come up right here with our logic?
Same thing.
Same thing. Right? Look, you've been shown how to do it mathematically, right? Am I going to be right there watching you?
No.
But you got to account for that at 1 minute, right?
Yeah.
Don't say 25 when it should be what?
26.
Yeah. You see what I done right there? That's a 1 there. It's 25. That works too. All right. Y'all ready?
Yeah.
Yeah. All right, let's go do some more. Holy smoke. Shane returned from a trip for Vegas for $400. Woo, that's 25% more than he had at the beginning of the trip. How much did Shane have at the beginning of the trip? You got So, okay, do we know how much Shane had when he took off the things? No, how do we represent an unknown in math? X. Now, what do we know about that money that he just had, X? What do we know? It's gonna grow by how much? 25% of that, right? Okay, good. When he got home, he had how much?
$400.
Good. So you go 400 equals 1.1. Now, divide both sides by what? X is equal to, ladies and gentlemen, $320. Okay. How did I get to 1.25? What's the coefficient in front of the X? 1.
Oh, you put it together, okay.
Combine like terms, right? Correct? Yeah. So he had 25% more than what he left with, right? Yes? So how do you represent that as a decimal? 1.25. But sometimes it's hard to get there. You got what he had plus 25% more of what he had, right? It's kind of like the sales tax, right? You got what you bought, and then here's your sales tax of what you bought off, right? Y'all remember that? It's kind of like that type of problem. And then you add them together, right? That's why you can say if it's a 7% sales tax, 1.07. Y'all got that? Yeah. Same thing here. The original, which is 1, that's 100%, plus a 25% growth, correct? 1.25 divided by 400. All right, so 320. If I take $320 and multiply by 1.25, what do I get?
400.
Thank you. Okay. Now, yes.
First X.
Okay. How much did we leave with? No, ma'am. No. We returned. What did you come from? He did. Okay. He came back with $400. That was 25% more than what he left with. What did he leave with? Well, we don't know that. So what do we call an unknown in math?
X.
Thank you. That's the one thing we don't have to go to for enough, right? We go, oh, what do we do? No, an unknown is X, right? Now let's figure out what we know about that. And life goes see. Pretty easy, right? There. Questions? No? Nope. It's what you got. He came home with $400. That was 25% more than what he had when he left, right? Then 25% of what he had is 25% more. What would be 25% of 320? Do 320 times 0.25. How much? If you take 320 plus 80, what do you get? 400. So this problem is nothing more than sales tax. Y'all understand that, right? Sales tax. How many of y'all, when you calculate sales tax? Yes, 8.25. Yeah, I got 300 seconds. Sorry. So it's like a sales tax, right? You gonna buy something, correct? And then you gotta pay, what, 5%, 6%, 7, 8, well.
It's 8 in Athens.
Oh my God.
You know that, Jordan?
No.
It's 8 in Athens and 7% like in Madison County, certain thing, but it's a higher tax than Athens.
Yeah, I am stop. Oh, okay. How much is it in Oconee County? Because that's where I
Probably
purchased.
12.
No.
Uh-uh.
It's either 7 or 8, but I think it's 7.